In this video, I would like to put everything together and discuss how we can use right triangles to evaluate trig expressions for angles in any quadrant. First, I'd like to return again to the question, where are the trigonometric functions positive on the unit circle? If we think about x equals cosine theta and y equals sine theta, the definition of sine and cosine on the unit circle, then we will see that all of the trig functions are positive here. In quadrant 1, sine and cosine are both positive, therefore tangent and the reciprocal functions are positive. In quadrant 2, sine is positive, the y value is positive, but the x value is not, and therefore tangent is not positive. Because sine is positive, cosecant, the reciprocal function of sine, will also be positive. In quadrant 3, sine and cosine are both negative. Because tangent is sine divided by cosine, tangent is positive in quadrant 3, and therefore cotangent as well. Finally, in quadrant 4, the x value is positive, so cosine is positive, and therefore secant is positive as well. Some people remember which values are positive in each of the quadrants by looking at the first letter of each of these words. A, S, T, C, or, as I learned it many years ago, all students take calculus. This is one way to remember which of the trig functions are positive in the various quadrants. So let's go on now to evaluate trig expressions using right triangles. There are 3 steps here. First, we want to find the reference angle. Then we will use a special right triangle to find the trig ratio for that reference angle. Finally, we will determine the sine. We need to have access to our special right triangles, so they are represented here. I encourage you to memorize these as you work on trigonometry. And let's put them to practice with evaluating some expressions. Cosine of 150 degrees. It's a good idea to try to identify what quadrant this angle is in. 150 degrees is quadrant 2, about right here, and the reference angle is 30 degrees. So step 1, find the reference angle of 30 degrees. Step 2, we can use the 30, 60, 90 triangle to find cosine of 30 degrees. Cosine of 30 degrees is adjacent leg over hypotenuse, so it's root 3 over 2. And finally, we can determine the appropriate sine. Because we are in quadrant 2 and we are evaluating cosine, cosine of a quadrant 2 angle is negative. So cosine of 150 is negative root 3 over 2. Here's our final answer. Next, we have secant of 5 pi over 4. Once again, let's try to identify what quadrant this is in. 180 degrees is the same as pi, which here we could rename as 4 pi over 4. 5 pi over 4 is further along in quadrant 3. The reference angle here is pi over 4. We can obtain that by taking 5 pi over 4 minus 4 pi over 4, and we get our reference angle. So step 1, find the reference angle of pi over 4, or 45 degrees. Step 2, let's evaluate the secant of 45 degrees using the special right triangle above. Secant is the reciprocal of cosine. Cosine is 1 over root 2 for a 45 degree angle, and so secant is root 2 over 1, or you could say root 2. Third, determine the sine. We're working with secant, which is based on cosine, and cosine in quadrant 3 is negative. So secant of 5 pi over 4, the original angle is negative square root of 2. One more example. Let's find the cosecant of 120 degrees. Cosecant of 120. This is also a quadrant 2 angle. 120 degrees is about right here. The reference angle is 60 degrees. Step 1, evaluate the reference angle of 60 degrees. Step 2, let's find cosecant of 60 degrees using a special right triangle. Cosecant is the reciprocal of sine, so it may be helpful to think of sine of 60 degrees from above. Sine of 60 is root 3 over 2. Therefore, cosecant is 2 over root 3. I would rationalize this, and it's more common to refer to this as 2 root 3 over 3. Third, determine the sign. Cosecant is based on sine, and in quadrant 2, sine is positive. So cosecant of the original angle in quadrant 2 is positive 2 root 3 over 3.